We are starting with the sixth lecture of algebra, and algebra is a very big topic. So now in this lecture, the focus is on simultaneous equations, quadratic formula. We have already gone over factorization and all these things. So now it's time for quadratic formula and word problems based upon simultaneous equations based upon quadratic formula. Now, first of all, this is the syllabus that you can see, and let me just go over what exactly have we done in the syllabus. It's a good thing to recap. When we talk about introduction to algebra and algebraic manipulation, simplifying expressions, expanding products, factorized by extracting common factors, factorized expression of these format, whether this is factorization by grouping, this is like difference of two squares, and you can cover it all up again when you go through the videos of the first two lectures. Whether it is something like this, that is either the expansion of a plus b whole square or a minus b whole square, whether it is something like this, which is middle term factorization or quadratic formula. And this thing cubic, this we will study shortly afterwards. This is basically taking common, and this would become x, and this is ax square plus bx plus c. So just by taking x common, you have again a quadratic expression over here. So we have done things like this, something like this. We have to do some more problems. Algebraic fractions. Yes, we did manipulate algebraic fractions when the denominators, let me highlight, when the denominators are constants. Something to do with multiplication, something to do with division, something to do with addition in which the denominators are variables, and something to simplify like this in which we would factorize the denominator. And then further on we will simplify. So all this thing, this is topic 2 in the new syllabus. So the new syllabus is for 2025 till 2027. So inshallah you will be giving in 2025 May, June. So this is the syllabus for you people. So these three things are done. This is indices 2, indices 1 is part of arithmetic. So we will study, we are using the concept, but we will study it further later on. So the orange one, this is basically for later on. So it's not yet done. Equations, construct expressions, equations, formulas. This is what we will practice now. Word problems. Solve linear equations and one unknown. That is basic. Yes, we have done this. Solve fractional equations with numerical and linear algebraic denominators. Something like this. Again, past paper questions. We will be doing them. Solve simultaneous equations, linear equations. That means straight line equations in two unknowns. So this we will practice a little bit more. Solve quadratic equations by factorization. This is done. Completing the square, this is again later on. So completing the square, that is later on. And the use of quadratic formula, that we will study in today's class. Change the subject of the formula, something very basic. We'll be doing some past paper questions, and there is this concept over there. Inequalities, again later on. And then sequences later on. And then proportion and graphs and graph of functions. So this basically, it's about proportionality and graphs. And this is like the second subtopic of this algebra. So basically in algebra, this also is the same thing, sketching the curves. And functions, that is something basic, that is also later on. So if we study this thing, I think it's spanning over 5 pages. So 2.1, 2.2, 2.3 is done. 2.4 later on, equations we are doing now, word problems we are doing now. This is coming up later, inequalities later. And the second part in upcoming lectures, we'll be focusing on proportionality and graphs. Once we are done with this, then we will move to the next parts of algebra. So algebra is something very, very detailed. Now let's talk about simultaneous equations. Let me select some equations. Y is equals to 6x minus 5. I'm just selecting it from the next page. And another one that is y is equals to 2x plus 19. Y is equals to 2x plus 19. Now, first of all, we need to understand what is a linear equation. We are not studying coordinate geometry as of now, but what exactly is a linear equation? Something of the form y is equals to mx plus c. Y is a variable, x is a variable. So y and x, they are variables. And when we talk about m, when we talk about c, so m and c, they are constants. So when we deal with such equations in which there are two variables and two constants, we call them a linear equation. But life is not that simple. We need to understand it further. So we need to understand this fact that not only there is y, there is x, the power of y is 1, the power of x is 1. And so let me write it more neatly. That is y and x, they are in the numerator and their powers, their index or indices. Index is singular, a little bit of English that you can learn from me, and indices is plural. So the powers, that is 1 each. So the power is 1, the power is 1 in the numerator. That is a linear equation. Linear means a straight line equation. Now we have to solve these two equations, solve the following pair of equations. So these are two equations that we will solve. And there are two unknowns. What are the unknowns? X and y. Y equals to 6x minus 5. This is equation 1. Y is equals to 2x plus 19. That is equation number 2. Now there are two methods of solving this. Method 1, that is called elimination. So what we do is that we write y minus 6x equals to negative 5. Y minus 2x is equals to 19. We change the sign, we eliminate one variable. Eliminate any one variable and find the other. So what if I change the sign of the second equation? This is negative y. This is positive 2x. This is negative 19. After changing the sign, I'll add. So look at the steps. Change, sign, and add. What is the objective? The objective is eliminate y. So if I eliminate y, when I add it up, this y and this y will cancel out. Negative 6x plus 2x, that is negative 4x. Negative 19, negative 5, that adds up to negative 24. Negative cancels out. X comes out to be 24 over 4, which comes out to be 6. That is the value of x. Now plug in the value of x in any equation. And what will you find? You will find the value of y. So basically, step 1, change, sign, and add. Make sure it's in the proper order. There is y, there is x, and constant is on the other side. There is y, there is x, and constant is on the other side. That is the first thing. The second step is this thing. That is, now plug in the value of the variable that you found. In this case, that variable is x in any equation. So for example, if the first equation is y is equals to 6x minus 5, y is equals to 6x minus 5, that is 6 into 6 minus 5, 36 minus 5, that comes out to be 31. Try it out in the second one. Y is equals to 2x plus 19, y is equals to 2x plus 19, that is 2 into 6 plus 19, that is 12 plus 19, which comes out to be 31. So both of them should give us the same exact answers. So that is simultaneous equation, linear equation, two unknowns, two equations, and x and y are variable, m and c are constants. Let me just put a box around it. So this is x and y are variable, m and c are constants, and that is how you solve this following pair of equation. So now let me move to the next page. And again, let me solve another way. So now again, we have simultaneous equations, two unknowns. And the next thing is they are linear equations. When you will study A-level math, you will have one linear and one unknown and one non-linear. So now over here, y is equals to 6x and minus 5, 2x plus 19. Now the other method that I use is that substitution. This is method number 2. What I do is that if this is equation 1, this is equation 2, from 1, y is 6x minus 5. Now plug in equation 2. So this thing, y is equals to 6x minus 5, that goes in this place. So therefore 6x minus 5 equals to 2x plus 19. 6x minus 2x, 4x is equals to 24, x comes out to be 6. Then plug value of x in any equation. Doesn't make a difference, just like before. So now if I write when x is 6, y is 6 into 6 minus 5, this comes out to be 31. Therefore the final answer, and make sure to write it separately, x is 6, y is 31. Similarly, final answer, write it separately, x is 6, y is 31. That is what you achieve. So now if this is all good, just acknowledge it on the WhatsApp so that I can check that you have understood it well. And if someone is a new student, they can just message me on Zoom if they don't have my WhatsApp number. So now let me just double check. There is Hisham, Khansa, Manaf, Nageen, Rafi, Jamal. So the new people, they can just message me over here. Okay, I'll check the messages a little bit later. Now let me just continue with this. So now it's time for solving a word problem. A word problem involving simultaneous equation. Now let's look at this question. It says, let me just enlarge it a bit. Okay, so now this time we are interested in word problems, and naturally it is related with simultaneous equations. Now it says a person Ada or other is X years old and Bill is Y years old. Last year, Bill was 6 times as old as Ada. Form an equation in X and show that it simplifies to this thing. Now, Ada is X, Bill is Y. Last year, Bill was 6 times as old as Ada. So, Bill is Y. He is 6 times as old as Ada. So, therefore, B is denoted by Y. That is equals to 6 times X. Now it says that is last year, but this is the current scenario right now. So first of all, currently there is Bill, there is Ada, the ages are Bill is Y, Ada is X. This is currently, let me just erase this thing. Actually, it's down. But last year, the age of Bill is Y minus 1, the age of Ada is X minus 1. And the relationship is that of 6 times. So last year, Bill was 6 times as old as Ada. That is 6x minus 6. This is Y minus 1. Make Y the subject. That is 6x minus 6 plus 1. Therefore, we have proven Y is equals to 6x minus 5. Now, it's only for 1 mark. And keep in mind, in O-level math, there is no half mark. It's either 0 or 1. Naturally, there are questions worth 2, 3, 4, 5 marks also. But there is nothing lesser than 1 mark. And when the examiner will check, either you will get it all right or you will get it all wrong. So the thing is, that is think, proceed, double check. Show all your steps. So think, proceed, double check, show all your steps. Over here, the double checking was easy. Why? Because the answer was given. And it was like a proof. You have to show that you get this thing. Is everyone clear on this? So now, what is the thing? Ada is X years old, Bill is Y years old. This was current. So this is the rate thing. So this is current. And the blue thing, that was about last year. So 1 year before, last year, make sure that you subtract 1 from each one of them. So 1 was subtracted, and then form an equation in it, and then this one, the purple one. That is this. Bill was 6 times as old as Ada. Bill was 6 times as old as Ada. That's how you get this thing. Now just acknowledge on WhatsApp if everyone understood this concept thoroughly and this thing. Now this word problem is tricky. Yes, let me explain it once again. Now when we do a word problem, we have to write down every single step. So let me just explain it once more. Do not copy right now. Just let me explain this in a very, very simple manner, even more simpler than what I taught. Now I'm starting all over again, no issue. The thing is, make a column. This is word problems. And the first thing is current and last year. Now there are 2 people over here. There is this person Ada, A and B in simple words. Let's not go with the pronunciation. Ada is X years now, Bill is Y years. Last year, that means a year before, the age was lesser. So this is X minus 1. This is Y minus 1. That is for last year. Were their ages equal? No, the ages were not equal. So what will I do now? I'll say, according to this equation, that Bill was 6 times as old as A. Last year, Bill was 6 times as old as A. So last year, this is A, this is B. B is 6 times as A, but this is last year. So this is the information for last year. So therefore, Y minus 1 is equals to 6 times X minus 1. Now someone asked me a question on WhatsApp. Is it clear? Just let me know. I'll pause the recording also, so you can ask me the question directly also. So now we have formed this equation, and that is the first thing that we have done. And this comes out to be Y is equals to 6x minus 5 after the expansion and everything. Now the next thing. Now it says in 19 years time, again write it in the same manner as before, current. So let me use the same color. That is purple, current, A, B, this is X, this is Y. And then it says in 19 years time, so that is after 19 years, X will be how much older? X plus 19. Y would be how much older? Y plus 19. So in 19 years time, now it's saying Bill will be twice as old as Ada. So Bill will be twice as old as A, but that is after 19 years. So this is after 19 years time. So this is the data for 19 years. Bill definitely has the edge. Bill is the eldest one. Y plus 19 is equals to 2 times X plus 19. Y plus 19 is 2X plus 38. Y is equals to 2X, 38 minus 19, that comes out to be 19. That is the second equation. So the second equation is also done. Is everyone clear on this? The first one was a year before. The second one is after 19 years. And we will do some more basic type of problems also. So let's move on. Hence find the present ages of Ada and Bill. So now there are two equations. Y is equals to 6x minus 5. Y is equals to 2x plus 19. Coincidentally, what I solved earlier was these two equations also. X comes out to be 6, Y comes out to be 31. Let me solve it again for over here. So which method you like, that's your choice. I'll use substitution. So just make it clear to the examiner the method that you are using. So we are using the substitution method. So 6x minus 5 equals to 2x plus 19. 6x minus 2x is 19 plus 5. 4x is 24. X comes out to be 6. And y is equals to 6 into 6 minus 5. This comes out to be 31. Ada is X. So Ada is 6 years old. Bill's age is 31 years old. So now let me minimize the screen. Let me stop the recording. This is an important question. It will form the basis for other questions that you will solve. So first of all, hold everything and copy this down, and then we will try out more problems. Now, what was this question all about? It was about two people. and those two people, their ages were represented by variable. That is where the algebra comes in. Ada, the person A, the age of Ada is X, the age of Bill is Y. Their current ages are X and Y. And let me just remove the screen for a bit so you can focus on myself a little bit more. So now, hold for a second. How can I increase this? Okay, so now you can see me, and the focus is on that understanding this concept, that where the algebra comes in. So now the algebra is about the X and the Y, that's the current ages. And then it's about this thing, which is that 1 year before, that's X minus 1, Y minus 1, and there is a ratio, I think 6 times. And then after 19 years, you add 19 to both of them, you form another equation. Again, the ages are not the same, one is twice that of the other. And then in this respect, you solve these two equations simultaneously for the two variables. The two variables represent what? X and Y, the ages, and you find the value of X and you find the value of Y. So that's what this question is all about. Now, let me just share the screen again. Okay, now I want you to try out an age question similar to this, if I can see it. No, there are no age questions over here, but there is a question about two numbers. So let me give you a hint first. So solve each problem by forming a pair of simultaneous equation. Question number 1. Find two numbers with a sum of 15 and a difference of 4. So let one number be X, the other number be Y. And then you should decide which one you consider to be small, which one you consider to be big. So if I consider X to be small, then Y is the big one. The first equation, the sum is 15. That means X plus Y is equals to 15. That is equation 1. And the difference of 4, a difference of 4, that means bigger minus the smaller. So Y minus X is equals to 4. That is the second equation. And now you would solve it simultaneously. It's your choice how you want to solve it. So the first equation, I can twist it around and write it like this. Y plus X is equals to 15. No harm in that. Agreed? Instead of X plus Y, I wrote Y plus X. Now if I add both the equations, which variable do I get rid of? I get rid of X. Elimination. So 2Y equals to minus X plus X. There is 15. Sum is 15 and the difference is 4. So 2y is equals to 19, and y comes out to be 19 over 2, and that comes out to be how much? That comes out to be 9.5. This is one number. The difference is that of 4, so therefore y plus x is equals to 15. 9.5 plus x is equals to 15. X is 15 minus 9.5, that comes out to be 6.5. So 15 minus 9 is 6 and 0.5, 5.5. So this comes out to be 5.5. Therefore, the final answer is X is 5.5, that is the small number, and Y is 9.5, that's the bigger number. There is no harm in double checking. 5.5 plus 9.5, 5 and 9 is 14, 14 plus 1 is 15. So that fulfills this equation. The difference between 9.5 and 5.5, that is 4. That also gives you this equation. Okay, so now this is good. Let's look at question number 4. The line with the equation y plus ax is equals to c passes through the point such and such. So now this is bit of coordinate geometry with simultaneous. This is x, this is y, this is x, this is y. So just plug in this equation. Y plus ax is equals to c. If I plug in the first point, when x is 1, y is 5. That's what it means. So 5 plus a times 1 is equals to c. This is equation 1. Similarly, 3, 1. When x is 3, y is 1. So therefore, 1 a times 3 is equals to c. That is equation 2. Solve simultaneously. A substitution is perfect. 5 plus a, that is c. 1 plus 3a, that is also c. So therefore 5 minus 1, 4. 3a minus a, that's 2a. Therefore a comes out to be 2. I plug in any equation. Let's say the first one. So equation 1. C is equals to 5 plus a, that is 5 plus 2. That comes out to be 7. That's how you get this. And then there are different questions for this one. Something to do with money. Something like this. A gardener, and let me just double check if this is all got by everyone. I hope this is all got because there is no complainers yet. Should I proceed? Shall I? Let's proceed. A gardener buys 50 carrot seeds. So there are 50 carrot seeds and 22 lettuce seeds for $1.10. So that is the cost. So this is 50 carrot and 20 lettuce. That cost 110 cents. I'm working in cents so that it's easier to work with. Her mother buys what? 30 carrot and 40 lettuce for $1.50. So that other value is, first one was 110, the other one is 150. So now this is 30 carrot and 40 lettuce. This is for 150 cents. Find the cost of 1 carrot seed and 1 lettuce seeds. So now let me introduce variable. First of all, I'm using variable c for carrots. So let the cost of 1 carrot be denoted by the symbol c, and we are working in cents. And let the cost of 1 lettuce seed be denoted by L. So L is for lettuce, L is for lettuce. Is this all got all clear? First equation is written in words over here. This is 1, this is 2. Now we have to use mathematics. 50C plus 20L equals to 110. Next one, 30C plus 40L equals to 150. 50 carrots, 50 times carrots, 20 lettuce, 20 times lettuce. That is equation 1. This is the cost. I'm working in cents. And then 30 carrot and 40 lettuce. 30 carrot, 40 lettuce. The cost is 1.50. So now this is equation 1. This is equation 2. It's your choice. I think I'll still go ahead with substitution. So therefore, 50C is equals to 110 minus 20L. C is 110 minus 20L over 50. That is what we get from here. So let me highlight this. Now plug in equation 2. Because we got from equation 1, so you cannot plug in the same equation. So let me just remove this at the bottom. So now plug in equation 2. So therefore, what do we have? 30C plus 40L is equals to 150. Now what goes over here? 110 minus 20L divided by 50. First of all, let me know very clearly, is everything okay till now? The symbols that I have used, it's a word problem. That is why the examiner has not given any symbol. You have to choose the symbol yourself. Is this all good, all clear? I need some activity on the WhatsApp. First equation in words, second equation in words, then I denoted the symbol, then I wrote the mathematical equation, then I'm using the process of substitution. That is the method that I'm using. Process or method means the same thing, so I'm using substitution method. From equation 1, I made C the subject. I have plugged in equation 2. Now it's time to simplify. So now let me cancel the 0 with the 0. Let me multiply throughout or both sides, means the same thing. Both sides by 5, so that I get rid of this denominator. So this 5 will cancel out. I have 3, 110 minus 20L plus 5 into 40L is equals to 5 into 150. I would be needing another page. 3 into 110 is 330, 3 into 20 is 60, 5 into 40 is 200L, 5 into 150 is 750. So 200 minus 60, 140L, that is 750 plus 330. How much is that? 700 plus 300, that's 1000, 1080. So 140L is 1080. Cancel of the 0 first. 14L is equals to 108. Therefore, make L the subject. Now I know that 14 into 5 is 70. And 14 into 2 is 28. So 70 plus 28, that won't serve the job. Maybe it's in decimals. So let me just divide using a calculator. So 108 divided by 14, that comes out to be 7.714. Maybe I made a mistake somewhere. So 50C plus 20L, 50C 20L, 30C 40L. That's good. 50C 20L, 110, 110 minus 20 divided by 50. That's good. 30C plus 40L. So the zeros cancels off. I'm multiplying by 3. I'm multiplying by 5. 5 into 40, 5 into 150 is 750. That is good. 3 into 20 is 60, 330, 750. 750 plus 330, that is 1080. That is also good. 200 minus 60 is 140. 200 minus 60 is 140. That is also good. It should not come out in decimals because it's a book question, so they won't give us the rounding off issue over here. So let me just erase this and let me just double check my working. So this is 30 into C. That's 30 into C. 110 minus 20L divided by 50. That looks perfect. And this is 40L and this is 150. Let me double check. That is 1.50, 1.10. It's all in cents. So this is 0, 0 cancel out, multiplying by 5. Okay, no, this 5 will cancel out this 5. That is gone. This is 5. This is 5. 5 into 40 is 200. That's good. 5 into 150. That is 750. 750 minus 330. Okay, that is the mistake that I made. 750 minus 330 rather than adding it. So 140L is equals to 750 minus 330, that comes out to be 420, and divided by 140, that comes out to be 3. So now it makes sense. L comes out to be 3. That means lettuce seeds cost 3 cents. Okay, so one small mistake and that consumed our time. So now let's move ahead, and I'm looking for C. 110 minus 20L divided by 50. 110 minus 20L divided by 50, that is C. That is 110 minus 20 into 3 divided by 50. 110 minus 60 is 50. 50 over 50 is 1. Therefore, the carrot cost 1 cents per seed. That is the answer, and that's how you solve this particular question. Now, let me pause the recording. I want you to solve out question number 8. So I've just minimized it. Look at question number 8 and solve it out. So now let's look at question number 8. It says a shop owner can buy either 2 TV and 3 DVD players for $17.50. Before I proceed further, TV cost, let me denote it by T. DVD price, let me denote it by D. 2 TV and 3 DVD, it costs $17.50. 2T, 3D, that is $17.50. That is equation number 1. Similarly, 4 TV, 1 DVD, it costs $12.50. 4T, 1D, it costs $12.50. That is equation number 2. If you were successful in forming this equation, congratulations. If you were not, then you have to read the question once again. You have to define the variable and then you have to proceed. So let's say which method to use. I can use elimination this time. So if I use elimination, let me take equation 2 and multiply by -3. So if I multiply by -3, 3 into 4 is 12t, 3 with a negative sign, -3d, and 1250 into 3, that is 3750. And the first equation is same as before. This is 2t plus 3d is 1750. Now the signs are already changed. That means d can be eliminated. So 2t minus 12t, negative 10t, 1750 and 3750, the difference is negative 2000. Therefore, t comes out to be 200. So the cost of TV is $200. Plug in the second equation. So therefore, 4t plus 1d equals to 1250. 4 into 200 plus d is equals to 1250. D is equals to 1250 minus 800. That comes out to be 450. So therefore, the cost of DVD is $450. That completes lecture number 6. And since we went into detail of simultaneous equations, so we only solved questions related to simultaneous equations, and this page just came somewhere in between. So that adjustment I'll do, don't worry about that. And the questions that are over here, the questions that are over here and here, try them out all the way till simultaneous. There are some more. Over here, this is also simultaneous equations. And so is this simultaneous equations. I'll attach the answers also. It's from the same book that we're talking about. And this one is also simultaneous equations. So just stop over here, and that is for lecture number 6. See you in the next class.